All right. In this video today, we're going to be talking about finding the domain of a rational expression. This is, in our rational expressions, one of the first places we've come across domains that were not all real numbers. And one reason for a domain that is not all real numbers is division by zero. We were told in elementary school that we could not divide by zero, and we still cannot divide by zero. In order for division by zero to potentially be a problem, then there must be a variable in the denominator of the function. So, to find the offending values that need to be thrown out then, to find the offending values of x, we set that denominator not equal to 0, and we solve. It's very much like setting something equal to 0, but in this case we're going to use a not equals to get our domain. So here we have our first example. State the domain of f of x equals 2 over 3x minus 5. Well, we do have a variable in the denominator, so this is potentially a problem. So we take the denominator, which is 3x minus 5. We set it not equal to 0. We solve that, so 3x cannot be 5, and x cannot equal 5/3. So that's one expression of our denominator there. We can use different things to express that in different ways, but this is probably the easiest one, so we'll stick with that, and we'll maybe talk about some of the other ones in class. All right, for our second example, we are going to state the domain of g of x equals negative 3x plus 2 over x minus 4 times 2x minus 1. In this case, I have two variables in the denominator potentially causing problems. So I set the denominator, which is x minus 4 times 2x minus 1, not equal to 0. This is in the zero product property form, so if this is going to not be 0, then that means x minus 4 cannot be 0, and 2x minus 1 cannot be 0. So this would mean x cannot be 4. This would say 2x cannot be 1, or x cannot be 1/2. And so I would say that my domain is x not equal to 4 and x not equal to 1/2. Right, those have been fairly straightforward there. We have one more example that we're going to take a look at. In this case, our denominator looks a little bit more complicated. We definitely have variables in the denominator, though. So there's a potential for things that need to be thrown out. And we will take that denominator, 3x squared minus 16x minus 12, set that not equal to 0, which means we're probably going to have to factor this thing. Okay, and so if we go into our factoring, we'll go ahead and grab the area model. We know that's got to be a 3x squared. That's got to be a minus 12, and these two have to add up to negative 16x. And so if we make this one a 3x and an x, that will make 3x squared. And because I've worked this out ahead of time, it will make a really good guess here for my next one. That gives me a minus 18x there and a plus 2x, which add up to the negative 16x. So that means I have a 3x plus 2 times x minus 6 not equal to 0. And then just like example 2, that means that 3x plus 2 cannot equal 0, and x minus 6 cannot equal to 0. So 3x can't equal -2, and x can't equal -2/3, and x cannot equal 6. And that is an and. We can't have either of those things happening, so my domain is x is not equal to -3 and x is not equal to -6. And that is how we find the domains of rational functions.